Captions in English, please. So this is the third video of chapter 9, and we will cover the definition of limiting reactant, theoretical yield, actual yield, and percent yield. So in many chemical reactions, you will not add a stoichiometric amount of each reactant. In most cases, you will have an excess of one or more reactant. The reactant in a chemical reaction that limits the amount of product that can be formed is called the limiting reactant because it limits the amount of product that you can form. Once the limiting reactant is completely consumed, the reaction will stop and only the excess reactants will remain because there is nothing with which it can react. So you will be left with some excess reactants, but the limiting reactant will be completely gone. And because of that, it will limit the amount of product you can make. Let's look at an analogy, and kitchen analogies are good here because when you're doing a recipe, you have ingredients and you're producing, for example, a grilled cheese sandwich. So the recipe is to use 2 slices of bread and 1 piece of cheese to make 1 grilled cheese sandwich. So that's our recipe. And, in chemistry, it would be our chemical equation. So it gives you the proportions of the ingredients that you need and how much of the product you can make from that. So 2 slices of bread plus 1 piece of cheese gives 1 grilled cheese sandwich. That's our chemical equation, if you will. And so let's say you have this question: how many total sandwiches can we make with 22 slices of bread and 15 pieces of cheese? So that's what is available in your kitchen, and you will make grilled sandwiches and as many as you want. So, as many as you can, sorry, I should say. So the way to solve this question is to determine how much product can be produced from each of the reactant without taking into account the other. So assuming there is enough of the other reactant. And then the limiting reactant will be the reactant that produces the least amount of product. So you're looking at how much product you make in each case. And the one that produces the least amount of product is the limiting reactant. So here, for example, you would take your 15 pieces of cheese. And so the conversion factor is taken from the recipe or in our chemical equation. And here the recipe says you're making 1 sandwich with 1 piece of cheese. So there is a ratio of 1 to 1 between the sandwiches and the pieces of cheese. And so that means you would make 15 sandwiches from 15 pieces of cheese. Now let's calculate the amount of sandwiches you can make from the 22 slices of bread. So 22 slices of bread is the given here, multiplied by the conversion factor that comes from the recipe. And the recipe says you can make 1 sandwich from 2 slices of bread. So 1 sandwich over 2 slices of bread because we want to cancel the units of slices of bread. And that means it's 22 divided by 2, and you can make 11 sandwiches from those 22 slices of bread. So we can make 15 from the pieces of cheese or 11 from the slices of bread. So you see that 11 is less than 15. So the maximum amount of product or sandwiches here that we can make is 11 from the slices of bread. This amount of product, the maximum amount you can make, and that's the least amount here, is called the theoretical yield. And so the limiting reactant or limiting reagent here is the bread, because that's the bread that will limit the amount of product you can make. Because once you've made 11 sandwiches, you can no longer make any more sandwiches because you're missing bread. So that's the limiting reactant. So suppose we cook our grilled cheese sandwiches and we accidentally burn 2 of them and 1 falls to the floor. So that means we would lose 3 sandwiches out of the total. So even though we had enough ingredients for 11 sandwiches, we finished only with 8 sandwiches because we burned 2, dropped 1 on the floor. So 11 minus 3 is 8. And so if this were a chemical reaction, the 8 sandwiches would be our actual yield. The actual yield is the amount of product actually produced by a chemical reaction, because it's never perfect. You never completely get 100% of the product usually. So from that, then we can calculate the percent yield. Our percent yield is the percentage of the theoretical yield that was actually attained. And so the formula for the percent yield is the actual yield over the theoretical yield times 100. It's a percentages, so that's why you need to multiply by 100. So in our case here, if we calculate the percent yield, it's going to be 8 sandwiches actually made over 11 sandwiches that we could have made from those, slices of bread and cheese, times 100. And so 8 over 11 times 100 is 73%. So since 3 of the sandwiches were ruined, then we got only 73% of our theoretical yield. So that's what the percent yield means. So to summarize, the limiting reactant or limiting reagent is the reactant that is completely consumed in a chemical reaction. The theoretical yield is the amount of product that can be made in a chemical reaction based on the amount of limiting reactant. So that's the maximum amount that can be made, but it's calculated based on the fact that it's the smaller amount of product that can be made from the limiting reactant. The actual yield is the amount of product actually produced by the chemical reaction. So in reality, we never have the theoretical yield. It's always less, and so we call that the actual yield. And so the percent yield is the actual yield over the theoretical yield times 100. So this allows you to know in percentages how much you actually got compared to what theoretically you could have gotten. So let's look at an example. If 1.8 moles of titanium reacts with 3.2 moles of chlorine gas to produce titanium 4 chloride, determine the limiting reactant and theoretical yield. So you're provided the chemical equation, and it's titanium as a metal, a solid, reacting with the chlorine gas. And there is 2 chlorine gas molecules per titanium reacting together to make the titanium 4 chloride, TiCl4, and that's a solid. So to answer that question, determine the limiting reactant and then the theoretical yield, you need to determine how much product can be produced from each reactant, assuming that the other reactant is in enough quantity. So you take each reactant and calculate the amount of product you can make from the amount of that reactant. So here, from the moles of titanium, the 1.8 moles of titanium, you use the fact that you will make 1 molecule of titanium 4 chloride when you have 1 mole of the titanium. So there is a ratio of 1 to 1, between the compound and the titanium. So that will allow you to calculate the amount of titanium chloride that you can make. And then using the 3.2 moles of chlorine gas, we will also calculate the amount of moles of titanium chloride that we can make. And this time the ratio is 2 to 1. You're making 1 molecule of the compound when you have 2 molecules of the chlorine gas. And so once you have calculated those moles of product that you can make from each of the reactant, the smallest amount of product that can be made will be telling you which reactant is limiting. So then the calculations look like this. You take 1.8 moles of titanium, multiply by 1 mole of titanium 4 chloride over 1 mole of titanium, because the proportions are 1 to 1 between these two. The moles of titanium cancel, and you obtain the same amount of moles of titanium 4 chloride when you are using 1.8 moles of titanium. You do the same with the 3.2 moles of chlorine gas. So 3.2 moles of chlorine gas multiplied by 1 mole of titanium 4 chloride made from 2 moles of chlorine gas. The 2 comes from the coefficient in front of the chlorine. And so that means you're dividing 3.2 by 2, and that's 1.6 moles of titanium 4 chloride that can be made from 3.2 moles of chlorine. And that's a smaller amount than 1.8. So the least amount of product that can be made is the 1.6 moles of titanium 4 chloride from the 3.2 moles of chlorine. So that means chlorine is the limiting reactant in this case, because it limits the amount of product that can be made. And then the amount of product that can be made here, the 1.6 moles of titanium 4 chloride, is the theoretical yield. So that answers the question.